నాకు కాల్ Yeah, good morning, all of you. I'm audible.
Yes, Veera, you are audible.
Okay, let me share my screen. Okay, so today concept is schedulers concept. So very important for interview point of view, very important. And also the concepts are little tricky to understand. The schedulers, we have a different methods in that. Okay, yeah. I hope my screen is visible. So this is schedulers topics. So far we discuss Kubernetes is going to deploy pod on nodes as per the default option. If user is not defined any specific node details, so by default, our scheduler component in control node is going to schedule the pod on any one of the node as per the resource availability. Okay, resource availability means node resource availability. So, and here we can write some conditions. My pod has to schedule on specific node. Okay, and it's not going to schedule on specific node, only schedule on specific node. Like there are some conditions we can give. Uh, so we have a different methods to schedule a pod on specific node. To understand these topics, we have a four concepts total. The one is node selector, node affinity, daemon set, taint, and tolerations. So these are the total four methods we have to learn to schedule the pod on specific node. The pod schedule is in your control now. Whatever condition you can give, scheduler blindly follow that condition. Scheduler is not going to take any default method to schedule a pod. So in this condition, the scheduler, whatever condition you are going to give, simply it will follow. The conditions are node selector, node affinity, daemon set, taint, and tolerations. So node selector is the simplest recommended from node selector constraint. You can add the node selector field in your pod specifications. So pod specifications, we have to add a node selector and specify the node labels you want to the target node have. Kubernetes only schedule the pod onto nodes that have each of the label you specify. So node selector is nothing but I'm going to select the node. My pod has to be scheduled on this node only. Then how you can define? So you can add node selector field to your pod specification. So where exactly? So if you can go here, pod specification is nothing but pod.yaml. If I go here, so this is my pod, right? So under specification, we need to write a node selector block here. After container 80, you just give a enter. Here you have to write a node selector block on the last line and give a labels. So what they are saying here? So you can add node selector field to your pod specification and specify node labels you want to the target node to have. I mean, we have to specify the node labels. So what we can understand, first we need to label the node. So you have to specify the same labels for that pod. So pod is going to be scheduled on that particular node. This is the concept. Okay. And so here, let me open the pane for better clarity. The first approach is schedulers. The schedulers concept. So the first one is node selector. Okay, understand. Here, two nodes are running. So node 1, this is node 2. Node 1, node 2. Excuse me. Next. So now this pod has to be scheduled on only this node. So in this condition, we can use node selector. Then how this pod can find only deploy on this node based on the label. So we need to enable the label here for this node. And on the pod section also we have to add the same label. So the pod will, your scheduler will find the node with respect to the labels. It will allow to create on this node only. So by mapping the labels. Okay. So now under pod section, where exactly we have to define these labels? That's what we learn here. So node selector field to you pod specification. So under pod specification, we have to add node selector field and also node labels where you want to target what you want to target the node to have. Means what here? So here you have to add node selector plus labels field. You have to be add these two fields into your pod so that whenever the labels will be matched, your pod is going to be scheduled only the specific node only. Okay, only the specific node only. Let's understand now. Meanwhile, it is running now. E case, let me open. Okay, ls cd kubernetes cd day 8 schedules. Okay, ls. Yeah, the first concept is daemon set, node affinity required, node selector, taint and toleration. We have different MLs. Let's focus on node selector now. If you can see till here only pod, and we have added here node selector field and labels. Label you can give any label, size equal to large, color equal to blue, name equal to whatever. Any set of pair you can give. I'm taking size equal to large. Whatever you can take it. So here if you can see the node selector labels I have added in the pod. If you can compare with the normal pod and the node selector pod, till here normal pod is equal, which is same. But the only difference is added here. Additional fields are node selector and size equal to large. I mean, the meaning of this pod is my pod is going to be scheduled only the specific node only. Okay, only specific node only. The specific node has to be matched with this label. Only this pod is going to be scheduled on the specific node. So in this concept, what we can understand first, uh, first node has to be created. Once node has to be created, we have to label the node. Once label the node is completed, once you deploy this pod has to be scheduled, only label the node. So select the node if my labels are match only. Okay, let's understand now. Still it is running. Okay. And the condition is here, node selector condition is if labels are mismatch. If labels are mismatch, for example, no node is enable the same labels for this pod. Your pod is not going to schedule any node. Still your pod is searching, your scheduler is searching the respective labels until and that your scheduler is not deploy the pod in any node. The only reference is this pod is going to be scheduled if the labels are matched. Otherwise, this pod is not going to schedule in the node selector method. In this case, any one of the nodes should match these labels. Otherwise, this pod is not going to be scheduled on any node. This is the concept. So first, what we need to do, I need to label the node. Okay, we need to label the node. So the label the node, how to label the node? kubectl, label nodes, node name, label key, label value. See here, label key means I'm giving size, label value large. Node name, kubectl get node, take that node and label it. So if I label my node size equal to large, for example, my pod also there already in the label size equal to large. So that my pod has to be scheduled on labeled, same labeled node only. It is not going to be scheduled, you know, other nodes if the labels are not matched. Okay. Yeah, done. kubectl get nodes. See, my two nodes are ready. So for example, okay, vi taint, sorry, node selector.ml is the first method. So here I'm going to schedule the apply the pod kubectl apply -f node selector.ml. Pod has created kubectl get pods. See, my pod is in pending state. My pod inform to scheduler. So my labels are size equal to large. So select the node and schedule the pod on specific node only. Now scheduler is verifying the nodes with the same label. So no node will be fine with that specific labels. That's what pod is only pending state. This is point number one. And if I label the node with the same pod labels, we'll see. Let me label the node. kubectl get nodes. So take any one of the node here. I'm taking this node. Okay. And go here. Label the node. Yeah, I'm giving here. Okay, kubectl, label the node size equal to large. Copy, paste. See, I label the node. Now kubectl, get pods. See, my pod is going to be creating now. Now scheduler immediately, okay, we found, so I found something here with the same labels. So immediately scheduler will be deployed this pod into the labeled node. Now kubectl, get pods. See, now running state. Now pod already running state, right? For example, if I unlabel the node, size equal to large, right? If I size hyphen, if I give size hyphen, whatever labels are done on the name of size key name, everything is unlabeled now. Again, I unlabel the node. So now no node will be there with no node is there with the same label. So we can check now this condition kubectl get pods. Still pod is running. The reason this node selector will work only at the time of scheduling only. Once pod has to be scheduled, even the node is unlabeled also, still pod will be running on the same node. This is node selector concept. Any questions?
No, Veera.
Okay. Okay. All are clear? Node selector concept.
Clear,
Yes,
Veera.
Veera. It's
Okay.
clear.
Three conditions. Before label, after schedule label, without label. This is a pod status. Okay. The next concept is ls. Let me delete. Okay. And one more concept here. Even normal pod. This pod can schedule on any node, even label node also. Okay. This pod can schedule on labeled node also. Node and there is no restrictions. I'm talking about node selector is pod and restrictions. So this pod can schedule on any node as we don't have any node selector restrictions here. Even label node also this pod is going to be scheduled. But labeled pod only schedule on labeled node. Unlabeled pod can schedule on labeled node or unlabeled node. Okay. Yeah. kubectl delete hyphen f node selector.ml or pod, whatever. kubectl get pods. Yeah. Okay. The next concept is daemon set. Okay. The daemon set is very easy to understand. The daemon set is concept is so URN, let's an example. URN, two nodes are there. Okay. If you create a pod, so this pod can schedule on each and every node. This is daemon set. That's it on. So how many nodes we have? Each node one pod will be created if you create a daemon set.yaml file. In the daemon set.yaml file, there is no any replica entry. So daemon set YAML is nothing but the kind is daemon set. Kind is daemon set so that whenever you can run a kind daemon set, by default, how many nodes we have, each node one pod will be scheduled. Okay. Let's understand now. vi.yaml. See, kind is daemon set. No replica entries are here. Even though if you create this pod, So if you create this pod with Nginx image, it will create two pods. But here replica, there is no replica entry, even though with help of kind option daemon set, here two pods will be created. Total two, we have a two nodes. Okay, let's kubectl apply -f daemon set. Kubectl get pods. Container is creating. So daemon set always maintain one, at least one pod and one node. That's it. Concept is. So in this condition, so two pods are running. The reason we have a two nodes. If I delete any one pod, see one pod has deleted, right? Again kubectl get pods. See, again one more pod is created. So daemon set is nothing but always create and maintain at least one pod and one node. If we have a 15 nodes, 15 pods will be created. That's it only. No need to mention a replica set. Replicas here. So always follow daemon set is nothing but how many nodes we have. So pods will be created to match the same number of nodes. Clear? The daemon set concept. Any questions?
It's clear, Vira.
Okay. Kubectl delete -f. So daemon set AML file, if you can see, there is no same like a deployment only. No difference. Only here daemon set will come. No change. And resource and request volumes, we can discuss. Volumes is not required. No, we can delete even here. Resource and request also. I will explain now. Volumes you can ignore, not required here. And if you can see, till here we already discussed deployment or replica set or whatever. Till here we already discussed. So here we can see additional one is resource and request. The 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 main usage of this fields we are adding in the pods. See guys, resources and we have a two kind of fields. One is limits, one is requests. One is limits, one is requests. So requests is nothing but whenever pod is creating on the node, right? So we have a node resources, I mean CPUs and RAM, and the pod has to take only 50 millicore CPU, 100 mega whatever megabytes only at the time of starting. And the limits are nothing but the max limit of this pod is only 100 millicore, 200 megabytes. Understand? So the meaning is, if you are not giving any control here, okay, if you are not giving any control here, maybe your pod, this pod can take 500 millicores or 1000 megabytes memory. But it's not like that. My resource, my node has to give only for this pod, highest CPU is only 100 millicore and highest RAM is 200 megabytes. That's it only. So if you give this condition like this pod, this application is running on this pod, right? If this pod has reaches 100 millicore and 200 megabytes, one more pod will be created as per the replica count. This is demonstrated. Just ignore it. Just I'm saying that. So the limits are nothing but this pod can take up to 100 millicore CPU only. If the required 101, this pod cannot withstand. This pod cannot take, I mean, node will not give the CPU to this pod more than 100. The reason I'm saying my pod has to be taken only 100 millicore only. If more than required, don't give. That's it only. Node will not allocate more than 100 millicore. At the same time, while starting time, uh, 50 millicore, 100 megabytes. While running time, 100 millicore, 200 megabytes. So this pod can share these resources from the node. So more than it is not possible. That's it only. The reason, so maybe uh, some situations, maybe your pod can take entire node resources also if there is no limitations. That's what this pod can support only 100 millicore from the node resources. And after that, this pod cannot withstand. One more pod will be created. I mean, system can understand this pod already maintain full load. 100 means. Okay, that's it. Yeah. Okay. The next concept is already two completed. Node affinity preferred, node affinity required. So node affinity preferred is similar to node selector. Even node affinity required also similar to node selector. But the difference is here, guys. The difference is node affinity preferred is nothing but in the if you can see this case, my pod always waiting for the same label. Otherwise, it will be it went on pending state. The pod went on pending state. After that, if the node label match only, the pod is got scheduled. My pod got scheduled. But here, node affinity preferred means this pod will check first if the node label match or not. If the match, this pod has to be scheduled on specific node only. If the pod labels are not matched, even though the pod is going to be scheduled any one of the node. So condition is preferred, not mandatory, just preferred. My preference is matching node. If node is not matching, no problem, you can schedule on any one of the node. This is the node affinity preferred. Let's understand now. Yeah. So node affinity preferred. So till here, same again. In place of node selector, affinity is coming. This is affinity block. Okay. So you just understand till here only. This is affinity block. Okay. Uh, this is block number 1. This is block number 2. So the first block, node affinity, we have a two kind of node affinities. Preferred during scheduling, ignore during execution. Preferred during scheduling, ignore during execution. So preferred during scheduling is nothing but what? Here, we can give the expressions in different way. Size, operator in means equal, value should be medium. Value is medium means size equal to medium. So the node affinity advantage is we can write here the conditions more expressive way. I mean, we have a operators conditions. So many conditions we can write like, so node selector only support size equal to medium, only equal operator only. But node affinity will support so many operators, but I'm taking only example, only one parameters, one operator only. So size equal to medium. This is the meaning of node affinity. Size equal to medium. If any label you can find, Give my preference. This pod preference is the specific node only. If the playable is not matched, even though you can schedule any one of the node scheduler. That is the meaning. Okay. So here again, one more condition is there. This is just one more condition is nothing but here. For example, my and two nodes are running. One node is size equal to medium. One node is size equal to small. So on which node this pod has to be scheduled based on this weight. So 51. This is weight number 1. This is weight number 50. If the labels are matched, the preference is size equal to small node only. The weight is more. If it is not there, any node, any label not match, always the preference is size equal to medium. Even the two labels are not matching, this pod can schedule any one of the node. Okay, let's understand now. So my end, I think all nodes are unlabeled. Yes, unlabeled. Yeah, size not found means no label, not labeled, and size equal to something. So what we can do, let's run a node affinity preferred. kubectl apply -f node affinity preferred method. kubectl get pods. See, my pod still, even though no labels are matching for any node, still even my pod is running. The reason, only simple reason. So here preferred scheduling time, ignore execution time. I will tell you what is execution, just leave it. Preferred scheduling time. I mean, only preferred, not a required, not a mandatory. If any node is labeled on this pod name, you can pod label, you can schedule. Otherwise, even though schedule on any node, this is node affinity preferred method. Okay. Now you can label. Also, no problem, no impact, no impact here. So your pod can schedule on any node, but the preference is if pod labels are matched with any node label, it will schedule. Otherwise, it will schedule on any other node also. But node selector is not like that. Node selector can schedule only label node. Otherwise, it is going to be pending state. Okay, this is node affinity preferred method. Clear or any questions? Any questions?
Clear, Veer.
Okay. Okay.
Veera,
Yeah.
uh, can you explain demonstrate YAML file once again?
Yeah. Where exactly your doubt is?
Like CPU's
That is
memory
not
usage,
about,
right?
that is not only for demo set. You can add this block for anywhere. Copy. So you can add here. So you can take any deployment.yaml. Sorry, not only here. Okay. So you can add here also. under spec like this. Okay. The meaning is 3 pods are going to be created, right? So these 3 pods are going to be scheduled on any node. 2+1 or 1+2 or 1, 1, 1, whatever the probability is. 2 pods may be run on one node, one pod may be run on one node. So your node resources, if you can consider as 100%. Node resources means CPU is 100%, memory is 100%. Out of 100%, this pod only we have to give 10%. 100 millicore means you should give only for this pod. This pod has to take from my resource from the node only 100 millicore. Still my node and only left 90 millicore, 90%. So memory is 200 millicore it is taking. Still my node and only 800 millicore for this one pod. So one more replica will take 100 CPU, 200 memory. Still my node and 800 millicore CPUs are there. 600 megabyte memory is only there. Next pod, it is taking 100 mil. Now my node and 700 millicore is there. 400 megabytes memory is only there. If I consider 100%, so the 3 pods are taking total 30% for CPUs. I mean each pod 10%, 10%, 10%. Memory is 20%. Each pod 20% memory, 20% memory, 20% memory. Still your node has to be give the resources for memory you can give for 2 more pods. If I calculate 5 replicas, 5 into 200,000. So still your node has able to give memory for 2 more pods. And still your node has to be able to give for 700 millicore for this uh, remaining pods. Like that we need to understand. Clear?
Yes, Veera.
Okay, I will show you here. You will get a clarity. This is my node. So my node and so this is my node resources. CPU is 1000 millicore. Just understand 1000 millicore, for example. Capacity. Memory is 1000 megabyte. Just understand this is my node resources. So this pod, for this pod, it is giving 100 millicore. If this pod will ask 101 millicore, this node will not give. The reason we have specified highest limit for my CPU of this pod is only 100 millicore. So 100 millicore till 100 millicore. If the traffic is more, it will give only till 100 millicore only, 80, 70, 60, whatever in between. But it is not possible to give 101. Same 200 millicore also. From this, it can give only 200 millicore for this pod. So still 1000 minus 100, still 900 millicore is able to give for other pods for this node. 800 megabyte memory it can give for other pods. Okay, and this is running time. At the time of starting, this pod has to take only 50 millicore and 100 megabyte. If something it is taking 51 at the time of starting, this node will not give for this pod. Your limit is only 50. I cannot give 51. Your limit is only 100 at the time of starting. Sorry, I cannot give more than 100 millicore. So we can balance the node resources. Otherwise, this pod can take 100% resources. One more pod can take only 10% resources. So node has not balanced here. One node can take 100%, one node can take only 10%. So to balance the node resources, we can give the limitations here, some resources. Clear now?
Yes, Veera.
Yeah. Next. So daemon set. So we can use this resource block anywhere. Replica set inside, pod inside, daemon set inside, deployment inside also. Yeah. The next concept is node affinity preferred already done, right? Let me write here. So node affinity preferred method. So in this method, your pod can schedule for example, this pod. So size equal to large. The condition is if you know node matches this node, okay. No label. This is also no label, even though this pod will be scheduled. Even though this pod has to be scheduled, any one of the node. But if the node has label size equal to large, no label. So this time, this pod can schedule on label node only. Preferred. Otherwise, schedule on any node. This is node affinity, preferred method. Next method is node affinity required method. Required is nothing but, so this pod can schedule only if the labels are matches. Otherwise, it is not going to schedule on any node. Okay, let me try. kubectl delete hyphen. Node affinity preferred delete. Next, kubectl. Okay, meanwhile, let me unlabel the node. I think already unlabeled, right? Okay. So my node has not labeled. Let's now run node affinity required. This is required dot. Oh, sorry. Vi node affinity required dot YAML. Same process, no difference. Here, one more option is not given here. Match expression not given. So here I'm giving only one node affinity required during now, not preferred during. Node selected terms, match expression, key equal to size, in operator, values, medium, small. We are giving list something here. Medium, small, large, list. Any one of the label, it can match only. This pod can be scheduled on the specific node. These labels need to be matched with any one of the node. Otherwise, this pod is not going to be scheduled. Let's try now. kubectl apply -f node affinity required.yaml. Created kubectl get pods. See, my pod is not going to be scheduled any one of the node. The reason this is not preferred method. This is node affinity required method. Required means definitely pod should be matched. Otherwise, it is not going to be scheduled. Now, vi here labels are medium or small, right? So any one of the label, if you can match any one of the label we can match for this node, it is going to be scheduled. Let me try to give the any one of the label. So size equal to, I think medium also there, right? Let's check size equal to medium is there or not. Yeah, medium also there. Now kubectl. See, now running. So matching labels are fine. Here is pending. After that is scheduling. Your scheduler, whenever the label node is same labels are there for the node, immediately scheduler is schedule the pod on the specific node. This is node affinity required mode. Clear or any questions? I'm unlabeling this. Unlabel, just give minus. So here you can give C, not only size equal C, you can give different one. Color equal to blue. Labels are you can give any name plus value. Unlabel means hyphen. That's it only. Color label hyphen. I'm unlabeling the node. Okay. Any questions for node affinity required?
Veera, I have a doubt.
Yeah.
Then what is the difference between node affinity required and node selector?
Yeah, very good question. Both are same, but node affinity we can give multiple values. So different expressions, different operators we can use. I mean, little advanced. So we can give different multiple conditions, but node selector only it gives only one value. Node selector, it will not support multiple expressions. Little old concept. Clear?
Clear,
But the
Veera.
concept is same. Yeah, concepts are same. Correct.
Then in real time, which
Node
scheduler we are
affinities.
building?
Node affinity we are using, not node selector.
Oh,
Yeah. Okay. The next concept is node affinity required means let me. Okay. So size equal to whatever values you can use, size equal to whatever you can give. Doesn't matter. Okay. Next concept is taint and tolerations. Okay. Now, what is taint and tolerations? Now, this concept we can see till now the four concepts, the restrictions are there in pod end. If the labels are not match, only pod will be scheduled, otherwise pod is not to be scheduled. All restrictions are there in the pod levels, node level. Even the node labels are not, pod will be scheduled for different conditions. But completely taint and toleration is completely about node level only. My end, two nodes are there. One pod is there. So in this pod is tolerate pod, for example. This is tainted node. So this node only accepts tolerate pods only. Node level, you need to see node level. And also tolerate pod can go to untainted node also. But normal pod, Normal pod can schedule. Normal pod can schedule only untainted node. This is not possible. Tainted node means restrictions. Only tolerate pod can go, but not normal pod. But tolerate pod can go tainted node or untainted node. Okay. Let me show you now how to taint the node. A taint is applied to node marked as having some special property that only certain pods can tolerate. If node has tainted, scheduler will not place a pod on that node unless the pod has matching tolerations. So now, okay, let me taint the node. The same concept, taint the node like label. Let me take this. Just now we have taken this, copy. Control V. So let's taint this node. I'm going to taint the node with app equal to blue. I'm going to taint the node with app equal to blue labels. Node has tainted. So this tainted node only allows tolerate pod only. Otherwise, it will not allow any other pods. Okay, I will show you now. My end normal pod is there, right? Yeah. Kubectl apply -f pod.aml. This pod only schedule on other node, not this node. The reason this node is tainted. This node can accept only tolerate app equal to blue. That pod only. This is normal pod, no tolerate pod. Yeah. Kubectl get pods -o wide angle. So we can see where exactly it is running also. You can just ignore this. This is previous one. Let me delete otherwise. Okay. See now, this is my tainted node, but normal pod is running on other node only, not tainted node. So this is tainted node. So tainted node only accept tolerate pod only, not for normal pod. Let's deploy tolerate pod also. Vi taint and toleration.aml. See here. Till here same pod. Here I'm going to add tolerations. See tolerations, same again. Key app operator is equal, value is blue, no schedule. Means if the pod can be scheduled app equal to blue on any node, this pod can schedule on specific node app equal to blue. Even though this pod can schedule on other node also, but node level we have to see this concept. So now this is tolerate pod. Tainted node only accept tolerate pod, not normal pod. So this pod can schedule on tainted node or untainted node. Pod level, if you can see, this pod can go tainted node or untainted node. Node level, this node can accept only tolerate pod, not other pods. Okay. Kubectl apply -f kubectl get pods -oy. So this is tolerate pod. See, tolerate pod schedule on tainted node. Tainted node. If tainted node is not there, definitely it should go for untainted node. Pod level, no restriction, but node level, definitely this node can accept only tolerate pod or no pods can be accepted here. Till here clear or any questions?
Clear, bro.
Okay.
Clear, bro.
No questions then?
No question, sir.
Yeah. So, and even here we have a two conditions, guys. For example, this normal pod is running on untainted node. Okay, normal pod is running on untainted node. If I taint this node, what is the condition of running pod? Untolerated pod. This is untolerated pod, right? That's what running in untainted node. If I give if I give here tainted node here now, this node also if I tainted, what will happen this node, this pod we can see now. Okay. On this node already one pod is running, untolerated pod is running. Untolerated means normal pod. So this node also tainted with app equal to blue. Now kubectl equal to kubectl get pods. Still running, no impact. But here, if I give no schedule hyphen means untainted. Again, if I give here instead of no schedule, we have a no execute. Same in the taint toleration, no schedule, we have a option no execute also. If I give this no execute tainted with no execute option, kubectl get pods. See, pod deleted from here. The reason no execute means no pods will be, even running pod also we can be deleted here. This tainted node. No execute means no pods will be executed. No pods will be run on this tainted node. No schedule means at the time of schedule only this will work. But only scheduled pod also can be deleted if you tainted the node with the different labels. Okay. Clear or any questions? But if the tolerate pod is running on untainted node, same condition in reverse direction. Toleration pod is running on untainted node. Okay. If you taint that node, even though there is no impact, it will not be deleted tolerate pod. The reason the pod is tolerated. But this pod is deleted is not tolerated pod. The labels are not matching. In the no executive condition level, the pod will be deleted. Clear or any questions? This is the final concept of schedulers.
Veera, I have one question.
Yeah.
No, if my pod is already running in the node with some other value like app is equal to blue, and we are tainting that node with some other value after execution,
Mm, mm.
will that run or
Which pod it is, tolerate pod or normal pod?
it's a tolerate pod?
There is no impact for tolerate pod.
Okay, even the value doesn't change, does not match. Also, there won't be any impact.
There won't be an impact.
Okay, got it.
The reason taint and toleration both can be matched.
Okay.
But one condition, if the labels are not matching, so in the node point of view, that pod is also untolerate pod only, even though tolerate, but labels are not matching, right? Still, that is normal pod only. This condition only won't be any impact, only taint and toleration. Label should be same only. If the labels are not same, even the pod will be deleted like a normal pod. See, tolerate with the same label, tolerate with not same label, without same label. Both are equal, both are not equal, right? I mean, normal pod which is equal to, you know, the labels are not matching pod. For example, if you can see here, this is normal pod. You just understand. This is normal pod. This is labeled pod, tolerate pod. So if it is a schedule on untainted node, for example, after that, if you can tainted means this both labels are same, no impact. Normal pod schedule on untainted node. So if you taint means even no schedule taint also no impact. Already pod is running, right? No execute will be impact. No execute means no pods will be run on this node. And again, tolerate with the different labels. Tolerate with different labels with the different labels of tainted node, which is equal to normal pod only, right? This condition will work, only label should be match only. Otherwise, tainted node can consider as a normal pod only. Clear now?
Yeah, got it.
Yeah. Okay. So, yeah.
Yeah, I have a question on yesterday's topic.
Yeah.
Yeah, I can't able to access Noteport application. Like, I have to give one Noteport IP address and the port number, right?
Yeah. But have
Yeah,
you enabled SG groups, all traffic?
yeah, I have given access
Which
to all
SG
traffic.
group you have enabled? Your client EC2, where you are interacting with that EC2 SG group or node SG group?
Client SG group, not the Node SG.
Then client application is not running in client server, right? Application
Oh,
is running in node servers.
Node. Okay, okay, got it, got it. Okay, I'll try
Yeah.
now.
Yeah.
Okay, thank you.
Okay, guys, that's all for today. So tomorrow we can discuss other topic and Kubernetes. Okay, and let me know, do you have any time in your hand to discuss further topics or any time restrictions to complete these sessions in 10 days, 15 days, so that I can filter important topics only? Do you have time in your hand, 20 to 25 days, or need to be closed in 10 days? Actually, what they're discussed at the time of this in agreement, you need to be closed these sessions in 2 months only, but we are almost enter into 2 months. So I don't have any issue. I'm ready to spend even 1 month and 2 months also. I need to give more subject to you. That's it only. But in your hand, do you have a time or not? That's I want to understand now.
Actually, we have time, but we discuss with them and we'll let you know tomorrow.
Yeah,
Is
please.
it fine?
You discuss with them and let me know so that I can
Yeah.
plan further sessions. Only important sessions I can take it. So,
Okay,
like,
tomorrow.
yeah,
Yeah.
if you, let me know tomorrow means so that I can prepare roadmap for coming 10 days for important topics, like you can manage up to 3 to 4 years experience topics.
Okay, okay, sure, Veera. Veera,
Hmm.
in the service concept, node port and load balancer both are for external communications, right?
Yeah, exactly.
Then what is the difference between those two? Like
See,
both are.
simple logic. If you deploy application on EC2 instance, leave about for Kubernetes. If you deploy application on EC2 instance, so how to give access? You need to give your EC2 public IP to public, right? They can understand easily this is EC2 public IP. So maybe they can easily hack your server, right? If they know your private IP of the server, they can easily log in your server also. So in the security point of view, that is not correct. What we are doing at the time, we have implementing load balancer concept instead of giving EC to public, IP to public, we are giving load balancer URL. In terms of security, load balancer URL, if I access through load balancer URL through my application, exactly I don't know my application is running on which server even. The reason, server IP is not published here, only load balancer URL only. So in this concept also, node port is, we have to give to public node IP plus node port. This is not a secure, right? Instead of that, we can give load balancer URL. No one can hack the load balancer URL. The reason load balancer is not a server, it's a service only. That's what high recommended action is, load balancer URL. Clear?
Yeah, yes, Veera, it's clear. Thank you.
Yeah. Okay, yes, thank you so much. So please let me know tomorrow the plan of action for upcoming classes so that I can prepare. Thank you so much. Bye-bye.
Thank you, Veera.
Thank you.